This presentation is going to be done by two people, myself and my colleague Richard McKinley, who is going to talk in the middle of the presentation about some of the practical problems that can occur and their solutions. Well, let's have a look at the categories of noise. What sort of noises do we hear in a hearing aid? Well, I think there are three categories of noise. There's environmental radio frequency interference, and there are more details about this in the addendum to this presentation that you can obtain in the online copy. There's also interference from the loop system itself, and once again, there are details in the addendum. But the main part of our talk today is going to be about environmental magnetic interference, buzzing, static, that sort of thing. Well, is noise really a problem? In my experience, many loop systems have no noise problem at all. And where there is noise, it can often be solved completely satisfactorily. And really importantly, the possibility of noise mustn't prevent audiologists from dispensing hearing aids with telecoils activated. I think there is sometimes a worry that noise will be a problem for hearing aid users, and this may stop some audiologists from dispensing hearing aids with telecoils. Briefly, I just want to describe what radio frequency interference sounds like. It's generally tones, warbles, static, that's higher frequency noises. And importantly, radio frequency interference can be heard with both the T position, T program enabled, and the microphone enabled. It can be heard when the loop system is not switched on. If you'd like more information about this, please have a look at the addendum at the end of this presentation. The interference that's generated by the loop system itself can be hum, buzz, crackles, whistles, but it's only heard when the hearing aid is set to the T position or program. It will stop when the loop system is switched off. So one way of identifying this noise is to switch the loop system on and off. Does the noise go away? If it does, it's generated by the loop system itself. And once again, we don't have time today to cover that. There's more information in the addendum. But on to the main subject of this morning's talk, environmental magnetic interference. What does it sound like? Well, it's hum, it's buzzing, it's crackles, and importantly, it's only heard with the hearing aid switched to the T position. And even more importantly, it's heard even when the loop system is switched off. So it's not noise that's generated by the loop system, it's noise that's present in the environment that the loop system is installed. How is environmental magnetic interference caused? Well, any alternating electric current creates an alternating magnetic field. And this is exactly the same way that an audio induction loop, a hearing loop, works. And because the interference is caused in the same way as the induction loop works, it's interference, it's sound that is picked up by the hearing aid. It can come from a wide variety of sources. Perhaps the most important is badly installed AC power cabling, and I know Richard is going to talk more about that. It can come from AC power transformers. It can come from electric motors, from electric heating systems, from the cathode ray tube, the tube type of televisions or display monitors. It can come from fluorescent, that's strip lighting. It can come from lighting dimmers. It can even come from other nearby loop systems. But how much noise is too much noise? Well, this is very subjective. What might be an acceptable noise to me would be an unacceptable noise to you, and vice versa. But if the loop system is going to be used for critical listening, such as in a theatre or a cinema, then the noise level must be very low, whatever the type of noise, whether it's a hum, whether it's a buzz, whether it's a crackle, it must be virtually inaudible, otherwise it's going to spoil the enjoyment of the program. But if the loop system is going to be used for short-term communication, perhaps at a ticket office, a teller's window, an inquiry desk, then the noise could be higher and still be acceptable. Because in a short-term communication where it's one-to-one, you have the opportunity of asking the person to repeat what they've just said if you haven't been able to understand it. Generally, if the noise spoils enjoyment or it makes it difficult to understand speech, then it's too noisy. But as I say, this is very subjective. Demonstration, I'm going to connect a loop receiver to the audio system in the theatre, and we're going to see just how bad or how good the level of noise is in this theatre. Now, people using hearing aids will already be listening to any noise that's in this theatre. Let's see if anybody else can pick up this noise through the audio system. What you're listening to now is the background magnetic noise in this theatre. And I think you'll agree it's pretty low. Can anybody hear a distracting noise?
I hear a high-pitched beep about every minute or so. Beep.
Okay.
Anybody else hear this?
Can anybody hear that on the audio system? No. I'm not sure where that beep's coming from, Juliet, but that's an interesting point, and we'll see if we can track that down. Thank you. What I wanted to demonstrate is that in many places, interfering magnetic noise is not really a problem. And since I've been here in Washington, I arrived here last Wednesday, I've walked around the hotels, I've traveled on the metro, and I've taken a hearing aid with me and listened critically to magnetic noise, and to be honest, I haven't really heard much. Now, there is an international standard. For those of you that like numbers, it's called IEC 60118-4. It's an international standard for loop systems, for the performance of loop systems, and it has technical requirements for environmental magnetic noise. It recommends maximum noise levels for different types of loop use. It recommends a particularly low level for critical listening, and it allows higher noise levels for areas, for uses where we're just using the loop for short-term communication. On a technical note, it requires measurement of the noise using an A-weighted filter. I won't go into the technical details of this now, but there are details available in the addendum to this presentation. But in simple terms, A-weighted filtering mimics the way that the human ear perceives sound. So it makes allowances for the fact that the human ear is less sensitive to low frequency and high frequency sounds and most sensitive to sounds in the middle of the frequency range. If you measure noise with a meter that has a flat frequency response, it is quite likely the readings will be misleading. So it's very important that an A-weighted filter is used for measuring background magnetic noise. Now, at this stage in the presentation, I'd like to hand over to Richard McKinley, who's going to take you through some more information about the sources of magnetic noise and how that magnetic noise can be overcome.
Thank you very much, Doug. I'm going to talk about some actual experiences with loop systems, but one of them from an installation and engineering standpoint is often the issue with the loop system interference has nothing to do with the hearing aid user. Something to be aware of is often the hum that the facilities agent, the person who is requesting the loop system to put in, will hear through the headphones of a loop receiver. And that becomes something that even though we look for the signal to noise ratio we want to give to the hearing aid user, is something that needs to be taken care of up front and handled, because somebody with relatively normal hearing and taking a loop receiver and turning it up can hear some hum and question the value of the loop system to the hearing aid wearer. What is the hum we actually hear? We call it 60 hertz, and it's relative to the electrical system. I should say the United States, we call it 60 hertz. It's various frequencies around the world. And there are what we call harmonics of that we hear. We're not actually listening to, in most cases, the 60 hertz itself, but we're listening to the third, the sixth, and the ninth harmonics of those frequencies. Doug talked a little bit about sources of magnetic interference, and we'll go into it in just a little bit more detail. And then in the end, we'll kind of summarize a little later of what improvements have been made and why, at least in the US, it's much easier to install a system relative to background interference today than it was even 10 years ago. Doug talked about fluorescent lighting, old tube TVs. We'll go through those. Fluorescent ballasts, in about 1990s, a number of the companies in the United States ordered millions of ballasts from a country on the other side of the seas, and they all came in bad. They all had huge amounts of ground issues. And the only really good part about that is none of them lasted very long. Somewhere around the year 2002, almost all of them burned out. I still do run into a few, but I have actually been into a church that just reballasted back in about 2000, the whole facility, and it was just a nightmare from one end to the other. But most of those ballasts are now out of the system, and most of them today are electronic ballasts going in, and we do not have issues with them. Also, the FCC, or Federal Communication Commission, implemented some tests since then that are required to determine the amount of emissions these products can give off. The third possibility with fluorescent lights, and we'll talk about that a little more, is that poor wiring is not uncommon with fluorescent lights. I often hear somebody say we have bad fluorescent lights, and you check it and you go through, and it's really the way the lights were wired by the electrician that's causing the issue. The good part is that's easily taken care of. Lighting dimmers and controllers, I often get a call and it says, I trace the source of the problem down, and it's the lighting dimmer or the lighting controller in the facility. It's not unusual to find a lighting dimmer controller where you take your loop receiver or your meter or whatever and you go up near it, and at a distance of 2 or 3 feet away, you will hear interference. But in most cases, the issue will go away once you're 2 or 3 feet away from the dimmer. But what does happen is often it's actually poor wiring after that dimmer, and we'll talk about that and do a demo in just a minute of what they do after that dimmer that's causing the issue. Again, with dimmers, we have some new technologies in dimmers that have come into effect around 2000 that have made dimmers much less, yield much less interference than they used to do. You can always find out if it's on a circuit by simply turning off that circuit and seeing if the interference goes away. Some of us remember tube TVs. Some of us remember even tubes within TVs. But tube TVs actually had a magnetic coil in them. Some of the manufacturers were famous for slightly leaving that coil running over time the way they did it. But that would cause some interference. Also the transformers within TVs. The good news is LCDs have almost zero emissions or interference that are produced today. AC power distribution, we're not going to get into all the theory of how it's distributed, and I will say there are different ways that AC power is distributed around the world. So I'm going to talk mostly at this point about AC power distribution in the United States. In ours, we have a star pattern in that the power originates, it branches out, and then it keeps distributing and branching out. And it's not circles. Some countries it's circle. Some countries use Earth as a return. But in our case, it goes out in a star pattern. And it usually goes through a number of wires. And depending on the distribution, the voltage, the transformers, it can be done on either 2, 3, or 4 wires in distribution, which should result in very little magnetic noise as long as an equal supply of current is flowing out one of those wires and the same amount of current is returning on one of those wires. The supply and return next to each other usually is in like the same jacket, or even when you look up on big power poles, often you'll see maybe they're 2 or 3 feet apart, but you should have the same amount of power going out one as you do. And one is flowing in one direction, one's flowing the other, and they cancel themselves out. Power distribution system interference from power lines is directly proportional to the separation of those power lines. I have seen it where I've gone by a facility where there's a major high voltage line out there, and the power lines can be separated sometimes by 10 or 12 feet. And I drive under them, and I agree I will find interference under those power lines. Generally 3 to 5 times the separation of those power lines, you can pick up some interference. I always recommend, I kind of have a little quick story here about an audiologist who decided to rent a facility that was very inexpensive. And I couldn't figure out why till I went, and I noticed the major high kVA lines for the whole city ran over their building. Their computers didn't work, nothing worked within their facility. It was a mess. They weren't in there very long, thank goodness. Electrical systems, and I'm going to sidestep the slide just 1 second. There's a term out there called ground loops. And I want to say that term is amazingly used to cover a number of different things. For some of you, you may even hear a slight hum in the audio system. I don't know if that's showing up in the loop or not. Sometimes it does. That's one form of a ground loop, and that's on signal cables. It's on the shield of signal cables. In major electrical systems, we also often use the term ground loop when the power does not return equally down the wire next to it. And what I'm going to demonstrate now is I'm going to create a return loop for you. And the power of this demonstration is I'm going to detect where it is, and I'm only going to use a loop receiver. You don't need any major pieces of equipment to do it. But we're going to need to do one thing when we do this demo. We're going to need to find both sources of the magnetic interference. If I have my 2 wires right next to each other in a jacket, an electrical jacket, I may have some interference, but remember the width of those 2 wires is only a 1/4 inch or a 1/2 inch apart, and for me to find a null over the wires is almost impossible. But hold on a minute and we'll do the demo. What we have here is a fancy electrical ground loop return. And I simply have a wire, this is single wire, and I have another single wire going across the table. I'm plugged into a power outlet, and from that, my load happens to be one of our standard very low wattage compact fluorescent lights. And what I'm going to show you is that when I turn this on, we get this on? Okay. Now, one other trick is this, and hopefully, is it real loud in the loop? It is? Turn it down just a little bit so it goes in. Okay. Real loud in the loop. Can you bring the loop for you? I want to do one demo. All right, I'm going to try it. Here it goes. It nulls. If you hear it, when I go right over the wire, it's gone. Same thing with detecting a loop system. But here's the trick. There's not just one. If I go over this side, I'm going to null. I go over this side. Okay, you can turn this off. I'll get rid of this fancy interference system here. The point is that anytime you have an interference in a facility that's a large area, in almost all cases, that large area has 2 points or 2 areas where more current is going out one way and returning another path. If you look in the picture on my slides, we're actually using a meter to go up, and we found one conduit and it nulled right over it. About 15 feet over in that facility, we found the other conduit. Now here's the hard part. It's not finding it. It's persuading the electrician to believe that there's an issue with the wiring in the facility. Because he'll come in and he'll say, the lights work. They all go on. That light worked, but the signal wasn't going out to the light and returning within the same cable. And that's what will happen. Some actual examples. We had a library conference room in Wisconsin. We went in and measured noise. We had minus 12 dB of noise. And they had some breakers in a panel. And what we found out was that we could literally shut off that electrical panel. We still had power going through the parts of those breakers because they were miswired from 2 separate sources. And the electrician came in, moved the breakers over to the other panel that they should have been in, and we ended up with minus 48 dB of noise. Not that long to do. He was quite convinced of finding it. We had another one where we traced out the interference and discovered that the power feeding a building at a college was actually returning down a steam pipe between 2 buildings. I would not want to have been the electrician to cut that steam pipe because I probably would not have been here today. The other one was that we found a loose wire nut or connection on a chandelier, and that loose connection was touching the conduit, and actually the conduit returning all the power from that chandelier is about 15 feet away, and it was very hot. They are findable, that's the point from it. And your loop receiver, if you can find the 2 points where the nulls are, you've actually found the locations where the current is going out one way and not returning down right next to it, but down another one. Distortion can also be found on power lines, and I think Europe is way ahead of us on this one, and a lot of their efforts now to get transformers to go down to low idle currents and reduce that. Because what distortion relative to power lines is that we have transformers, all our devices we plug into the wall to power our computers and laptops and all those. Instead of returning all of the current back to the power company down the neutral line, it goes some of it through the ground. And power companies look at that as a distortion number. The good part in the United States is there's a standard out there, 519, which gives a recommendation for a maximum distortion. Nothing enforceable, sadly, at this point, but a recommendation. And I want to say I have had great success with asking power companies to come out and take a look at it with me. Sometimes anywhere from 2 in the morning till 5 in the morning, I've had as many as 6 or 8 trucks out. And often we found out which subdivision had the issues and where all that distortion was coming from and rerouted it so it was not going by the facility that we wish to work with. The good news, fluorescent lighting New FCC rules, a lot of the old lighting that was out there is gone. That source is being pretty well removed today. Tube TV monitors, no new production for them, not in the United States. That's good. The LCD monitors, no major issue. Dimmers, dramatic improvements in the dimmers, but even at that, they're usually not the source for the interference. They may have a slight amount of interference 2 to 3 feet from them, but they aren't the reason that you're taking a whole section of a room out and causing major problems. Electrical wiring issues or ground loops, whichever you want to call it, yes, but it can and should be detected. Interestingly enough, that library where we found the problem, the IT person called me about a month later and said, I have about 1/10 of the computer problems that I used to have since we solved that electrical wiring issue. But before we did that, every light, everything in the building worked. It was just wired wrong. And distortion on power lines, there is some specs out there to help. They're not specifications that are anything other than enforceable guidelines at the moment, but it's not a common issue. And I will say in many installs, I can only say I know of 4 facilities that to date have not been looped because of power line distortion. In those cases, it was all power line distortion. Magnetic noise interference, far less today than it was 10 years ago. When I first started doing loops about 12 years ago, there was an issue with it, and we had to handle it a lot. Sources of electrical ground loops can be found and taken care of. New LCD TVs, computer monitors, they don't cause interference. That's great. That helps a lot, especially when you're doing counter or loops for people, customer service loops. And most of the time, interference is below -32 is not an issue. So I'll turn this back to Doug and let Doug finish the presentation. Thank you very much.
Okay, thank you, Richard, for that. Just looking at a few case studies that I've been involved with in the UK, very similar to Richard's experiences. We had problems with a ticket office that had the old-fashioned tube displays. Simply moving the display had a big effect. Simply turning it around slightly changed the position of the magnetic field and made it very acceptable for hearing aid users. Even better was to replace the tube display completely with an LCD or an LED type, and that got rid of the noise completely. Another problem with a laser printer. Close by the laser printer, people with hearing aids picked up a lot of noise when they were in the T position. So we switched the printer off when the loop isn't in use. Result, no noise. Richard's covered hum and buzz from lighting power circuits very well. In the UK, we used to have a lot of problems, especially with fluorescent light fittings where the line and neutral, that's the source and return conductors, took separate routes. As long as the AC power cabling is reinstalled with the line and neutral conductors in the same jacket, in the same sheath, no noise. Buzz and crackles from an air conditioning plant. I had experience with a synagogue in London where we had tremendous noise running right down the middle of the main room, and it was traced to old-style thermostats being used in the air conditioning plant and equipment with the cabling, the supply cabling for that running under the floor. The thermostat devices were replaced with modern, low interference types. Result? No noise. So what can we do about the noise? Richard's described using a hearing aid or a receiver to locate the source, if that's possible. You could try switching off electrical equipment until the noise stops. Certainly contact the venue management and alert them to the fact that there's a noise problem there. Hearing aid users, perhaps more in the UK than in the US, are a little bit reticent, a little bit reluctant to complain, stand up and complain. But stand up and complain is exactly what you have to do. Alert the venue management to the disability legislation. The hum and the noise is preventing you from accessing all of the facilities that you should be able to access. Hit their wallets. Tell them about the potential loss of hearing aid users' business if hearing aid users can't use the venue. And contact the owner of the interference generating equipment, which might be the power company. Again, make use of the disability legislation, advocacy organizations like the HLAA. But what can you do if the noise level is still too high and you still need hearing assistance? Well, there are alternatives to loop systems. There are infrared or FM systems. They use neck loops or silhouettes. Those are, in the UK, are called ear hooks. They still need the telecoil in operation, so they can still pick up the noise. But especially with a silhouette, which can put out quite a strong magnetic field, it may be possible, with that stronger magnetic field, to turn the volume control down on the hearing aid. And in doing so, you turn down the volume of the noise as well. If the infrared or FM system provides headphones, then those headphones have got to be suitable for hearing aid wearers. And Dave Myers this morning at breakfast gave us some very useful information about how headphone systems can be a problem if they're not compatible with hearing aids. Another alternative is direct audio input, audio shoes or boots, where the audio signal on a wire can be connected directly to the hearing aid. And there are new technologies becoming available, Bluetooth or other wireless technology. But some of those are in the future. The systems that are available at the moment for Bluetooth are a little bit battery hungry, but maybe new technology is going to improve that. Well, I just want to take a quick review of what we've been talking about. And Dana, I hope you're going to thank us because we're going to finish well in time. We've looked at causes of environmental magnetic interference, which can often be assessed and resolved quite quickly. And we've described processes by which you can remedy magnetic interference, and also who needs to be involved in that process. And we've also mentioned compliance with the international standard for audio frequency induction loop systems, and that, as well as describing how strong the field should be and where it should cover, describes how low the magnetic interference should be. But most importantly, I hope that Richard and I have convinced you that if noise is a problem, then it can nearly always be overcome. So in conclusion, I'm sure Richard would join me in saying thank you very much for listening to us this morning. We hope that it was a good presentation for you. We want you to think about what went well, what could have gone better, and importantly, what else do you need to know? And if you'd like to, please feel free to contact either myself directly or Richard, and those are the two email addresses. And for those of you that are interested in the subject of magnetic noise, of balanced circuits, good grounding systems, I strongly recommend that you visit Jensen Transformer's website. There's a guy there who has written some excellent papers on grounding systems and on how to troubleshoot hum, noise, and buzz issues. His name is Bill Whitlock, and he's a bit of a guru in the audio engineering world. So thank you very much indeed for your time this morning. And as I say, Dana, do we get brownie points for finishing early?
We probably do have about 5 minutes if anybody has any questions they want to ask. And rather than bring a mic down, if you don't, we'll repeat the questions for you. So, yes.
The biggest problem I have with magnetic interference in my newer automobile.
Her question was related to magnetic interference in the automobile. We should have Dana on this one because I guess you've got to see her car to get that answer. But I will tell you that I have a good friend who just went shopping for a car and went out, and she tried about 12 until she found the 3 that she decided to pick from. There's a lot of variations in how they do the wiring, the spark control. Newer cars are better than older cars. They've done a lot electronically to help with the new cars that were problems with cars 5-10 years ago in time. But there are some cars that are extremely quiet. I know when the black taxis were done, they did some spark plug wire and other changes within the black taxis in England to get them correct. So, You're done. Go ahead. Oh, go ahead.
There is another advantage with the London black taxis. Most of them are diesel engines, so they don't have spark plugs, which is an advantage. One thing that might be worth bearing in mind with in-car loop systems, the point I mentioned about silhouette or ear hook solenoids, because of the stronger field that you can get from those, you can turn down the volume control on your hearing aid a little, just to reduce the level of noise as well. But beware of turning up the signal from the silhouette too much, because that can cause overloading and distortion in the hearing aid. So you need to strike a balance between strong enough signal to overcome the noise, but not too strong that it causes distortion.
I hear it better than in there. And they couldn't fix it. They came over to somebody and said, turn off your technology, like our side, the side of
just walk down the street. I've done this on many streets in New York City. And I would say that on average, I would say that okay, I don't understand. You're walking down your
I was in for this.
noise and
And all my computer was
about cities or certain places might have more problems.
and they couldn't fix it. They tried. They helped.
Restaurants, let me address it. He was saying walking down the street in like New York City and many cities, there are issues that he's run into with interference. One of the problems, especially with an older city, and New York City is definitely older, is thousands of people have changed thousands of wires over time. Generally, thank goodness we're not doing our symposiums on the streets of New York City. So yes, there are places like that that are going to have a large amount of interference. And even in looking at facilities and restaurants, what I've found is when I go into a brand new restaurant and one electrician has worked on it, it's probably pretty good. But now they add lights and structures and remodel over the years, and these other ones come in, not being bad, but they find the quickest way to add another light or the quickest way to add another dimmer. And right now, we do not have a means in the inspections in cities to check for ground looping. One of the things you can do is over time in advocacy is I'd love to get that test requirement into the building codes. So it's something, and actually a lot of other people would like to have it. The audio guys would like to have it. It affects their job, the computer people, everybody. So, one more question?
Yes, I have a question
I haven't been able to find it.
wholesale retail businesses that use security systems when you're in the store. There's a great deal of interference as far as hearing aids. Yeah, you have a recommendation.
Yeah, the question is that in a lot of retail outlets, there are security systems that use magnetic induction systems to detect things like clothing tags being taken out of the store. And certainly if you're close to those systems, they're usually located at the exits of the store, then there can be quite a high level of noise. But in addressing that point and the point about the noise in the environment, in the streets in New York, there is an optimum setting for the sensitivity of the telecoil in a hearing aid. And from some of the discussions that I've heard on the Loops and Telecoils email group, It's possible that some audiologists are setting the hearing aids too sensitive in the telecoil position, and it's possible that this extra sensitivity is causing people to think that there is more noise problem than there actually is. Now, there is a standard for the setting of the telecoil sensitivities, but it may be that some audiologists either are not fully aware of the standard or not sure how to adjust the telecoil to that particular sensitivity. So there's two sides to every coin. There is the level of noise, but there's also the sensitivity of the hearing aid to that noise. And if a hearing aid is set up correctly, our experience in the UK and Scandinavia is that environmental magnetic noise is not generally much of a problem. Thank you very much.